so you just watched a video with Mr. Wagner walking you through the reasons that we have seasons. And so right here where it says problem, I don't want you to necessarily write a problem, but I do want you to write the 2 reasons we have seasons. So the first reason that we have seasons is because the Earth is tilted. And then the next reason that we have seasons is because of the revolution of the Earth around the sun. So those are going to be the 2 reasons why we have seasons. If we aren't tilted, then seasons wouldn't happen, and if we didn't revolve around the sun, then seasons wouldn't happen. And so we have to have both of those 2 things for seasons to occur. Okay, so now let's look at our lab paper, and you're going to fill a lot of this out based on the video that you just watched, but I'm going to do a couple of these problems with you. And so the first question asks, what is wrong with the position of the globe? And so the problem is that the globe is not tilted. We know that for seasons to occur, the globe has to have a tilt to it. And so we're going to draw an Earth that is tilted, just like that. Okay, and what is wrong with it? It is not tilted. And then it's going to ask, what does the light at the center of the room represent? So the light is going to represent the energy that we are getting from the sun. Okay? And so then the rest of this worksheet is really going to follow the video that you've already watched. So if you need to go back in and rewatch that video to answer some of these questions, then I absolutely want you to go ahead and do that. And you're going to finish answering a lot of the questions that you see on this paper independently with that video. One of the questions down here at the bottom though says, look at the labels for the distances from the Earth to the sun, and it wants to know what is unexpected about that. So when we look at these numbers, this position right here is going to be summer. This is fall. We're going to go counterclockwise. So that would make this winter. And this up here is going to be spring. So if I look at the distance between the Earth and the sun for summer, I see that we are actually further away from the sun in the summer position than we are when we are experiencing winter. Okay? So distance to the sun does not determine seasons. What is going to determine seasons is going to be that tilt. And so when we're tilted towards the sun, we're going to be getting summer. We can see that in this position. When we're tilted away from the sun, it's going to be winter. We're going to have less energy from the sun. And so that's going to cause it to be cooler. And it's also going to cause shorter hours of day. And so now what we're going to do is we're going to move on to the next activity, which is to take notes over equinoxes and solstices. So I want you to go ahead and finish this paper up, and then when you are finished, you're going to continue this video and take some notes. Alright, so now you should be ready to take some notes on equinoxes and solstices. And so on this paper, you're just going to fill in the blanks. The red words should be what you want to write on your paper. So a solstice is a day that is either very long or it is very short. And an equinox is a day that has the same number of hours for both day and night. So equa in the word equinox means equal. And so that's where we're getting that equal hours of day and night. Okay, the summer solstice is the longest day of the year, and this day lasts for about 15 hours. It usually occurs on the 21st of June every year, and this is the official start of the summer season. So if I look at this model, and I want you to draw this model on your paper, but when I look at this model, I can see this little portion right here is going to be the daylight hours because that's the part of the Earth that is illuminated. And you can see that the number of hours that we have for day is a lot greater than the little piece that we have for night. So our days are going to be much longer in the summer solstice, and our nights will be much shorter. But if we look in the southern hemisphere, we can see that the opposite is true. So here in the southern hemisphere, it's actually their winter, and so they have very small amounts of daytime hours. But if you look at their night, they're experiencing longer nighttime hours. Okay, so this is going to be the summer solstice. This is when we are experiencing summer. And I want you to go ahead and write this on your paper. Remember, if you need to pause the video so that you can get everything on this slide written down, go ahead and pause it and then pick it back up when you're ready for the next chunk of information. Okay, so the next type of solstice is going to be the winter solstice, and the winter solstice is going to be the shortest day of the year, and this day usually lasts for about 7 to 8 hours, and it usually occurs around the 21st of December, and this is the official start of the winter season. So I want you to draw this model, and when you look at this model, you can see the hours that we have for day are very small compared to the number of hours that we have for night. And so winter daytime hours are going to be very short, and then nighttime hours are going to be very long, and this is because we're tilted away from the sun, so we're not getting direct energy or light from the sun, and so it's going to cause it to be cooler. It's also going to cause the difference in the number of hours for day versus night. If we look at the southern hemisphere, though, we can see that this is their summer. It's tilted towards the sun, so they're going to have very long hours of day, very short hours of night. Okay, and so now we have two equinoxes that we're going to talk about. Remember, equa in the word equinox means equal. So we're going to have equal hours of day and night. The vernal equinox usually occurs around the 21st of March every year, and this is the mark of the start of the spring season. And then the autumnal equinox usually occurs around the 21st of September, and this is the mark of the start of the fall season. Okay, and then here is your picture for the vernal equinox and the autumnal equinox. Notice how we really can't tell day versus night on this particular model, and that is just because when we're looking at spring and fall on a seasons diagram, we really cannot see how much sun is being projected onto the earth. Okay, so some pretty generic models for you to draw on your paper. Okay, so now we're going to look at these models all put together, and I want you to turn to the back of your paper, and we're going to label both of these models that you see. So this is just a sun, earth, seasons model, and what you're responsible for knowing is how to label the seasons on this particular diagram. What you need to do first is find summer in the northern hemisphere, and so to do that, we're going to look to see which earth is tilted towards the sun. So this particular earth over here is tilted towards the sun, so this is going to be the summer solstice. And we're going to go counterclockwise around the sun. So every day that we see between this position and this position is going to be our summer. And then we're going to go in order of the seasons. So next we would have the autumnal equinox. And every day between that position and this next position would be fall. And then we're going to have the winter solstice. And every day between that position and that position will be winter. And then we are going to have the vernal equinox. And every day between here and here will be spring. So when we look at this particular diagram, really what we're labeling are the seasons, the equinoxes and the solstices. So the summer solstice is just one day of the year, and it happens to be the longest day of the year. So that's where we have the most hours of day in the entire year. But what we see is every day between this point and this point is summer, but as we move around, the day is actually getting shorter. So shorter, 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 till I reach this point, and I'm going to have equal hours of day and night. But it's going to continue to get shorter. So every day from here to here is going to be about a minute shorter than the previous day until I get around to the winter solstice. And this over here is going to be the shortest day of the year. But now what's going to happen is the days are going to start getting longer by about a minute every day. So longer, 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 longer until I get here and I have equal hours of day and night. And then longer, 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 longer until I get to the longest day of the year. Okay, so this is just one model that we're responsible for knowing. So this is going to be the second model that we're responsible for. And the only difference is that the Earth is tilted the other direction. So again, we want to find summer in the northern hemisphere. And we're going to look at tilt. So this particular Earth is tilted towards the sun. So this is going to be summer in the northern hemisphere. We're going to go around counterclockwise. So this position up here would be fall. Keep going counterclockwise. This would be winter. And then this down here would be spring. So remember that this is just for the northern hemisphere. We also need to know what's happening in the southern hemisphere, and it's just opposite. So if it's summer in the northern hemisphere, it is winter in the southern hemisphere. If it is fall in the northern hemisphere, it is spring in the southern hemisphere. If it is winter in the northern hemisphere, it is summer in the southern hemisphere. And if it is spring in the northern hemisphere, it is fall in the southern hemisphere. Okay, so I want you to go ahead and get these diagrams labeled. And what I want you to do when you're done with that is I want you to put this in your notes, and I want you to save it for tomorrow. We are going to take a quiz on both activities, so both your reasons for the seasons lab and then also your equinox and solstice notes page. It should be an easy 100. All of the questions will be directly off of your notes and your lab paper. So you want to make sure that you are saving both of those. If you finish before the bell rings, I want you to log into Boom Cards, and I want you to practice the moon phase set that is there for you. If you need to practice drawing and writing your moon phases, you can also do that. But you are engaged with something related to science until the bell rings. If you have any questions, please let me know tomorrow when I come back, and we will be ready to take that quiz as soon as the bell rings tomorrow. I hope you all have a wonderful day.